Hello and welcome. Today we're going to look at a linked list problem. It's a Leetcode 2, add two numbers. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contains a single digit. Add two numbers and return the sum as a linked list. You may assume that the two numbers do not contain any leading zero except for the number 0 itself. And here we have some examples. So have 2, 4, 3. 5, 6, 4, and it will give us the list 708. The numbers are reversed though, so it's 342 and 465. So let's go and explain this via drawing. So we have 2, 3, 4, right? And I think 5, 6, 4. 2, 3, 4, and 5, 2, 4, 3, sorry. Two, 4, 3, and 5, 6, 4. 5, 6, 4. Okay, so these are our two lists. So we want to compute a third list. It's going to be 7, 0, 8. So how would we go about doing this? Well, we can straight away iterate through the two lists and add the numbers. So we can add 2 plus 5, then we add 4 plus 6, and then 3 plus 4, and we get to our result, right? So the only thing we have to take into consideration here in addition to that is that we have a carry. And when we do, for example, 4 plus 6, that's going to be 10. So we need to carry over to the next position, where we'll have 3 plus 4 plus 1, the carry, yielding 8. So in order to do this, we initialize the carry with 0, and also the sum as for the current iteration to 0. Okay. And then we loop, we iterate, and we ask if we have list L1 or list L2 not null. So if either of these lists exists, we want to continue and keep adding numbers, no sum, because we can, even if one of them doesn't have as many elements, we still want to continue to add as long as we have some elements in any of the lists. Okay, and then when we initialize the sum, we initialize it at the beginning of the iteration with the carry, right? So here we initialize the sum with the carry, and then we add the two numbers. So we add s plus 2 and then plus 5, because L1 has the head 2 and L2 has the head 5. So then we iterate forward to the next element, and we create a node 7. Create a node 7. Okay, so then we go back. Well, before we do that, we need to update the carry and the sum, something we didn't do. So the sum is going to be just modulo 10, because we want to extract the digit, and the carry is going to be sum over 10. So in case we get a number like 12 or 13, the carry would be 1 and the sum would be 2 or 3, right? So that's the idea behind what's going on here. So in this case, carry is going to be 0 and sum is going to be 7, and that's why the node is 7. Then we go back up, we check L1 or L2, and we can see that they are valid, they are not null. We initialize s with the carry, which is 0. Then we add 4 and we add 6, and we iterate for both of the lists. Okay, and now in our result we will have here we will have a carry equals 1 and sum equals 0, because we have 10, right? So then we have 1 and 0. 10 over 10 is 1 for the carry, and then 0 for the sum, since we're taking the modulo of 10 to itself. So we add the new node 0, and we go next. We need one more element, so we iterate again because our lists are not null, and s is going to be 1 this time because carry is 1, and then we do s plus 3 and plus 4, and then we iterate forward. Both lists are now null, and then we have carry is 0 and sum is 8. 4 plus 3 plus 1, 8. That's it. We have our result. So the only important part is to remember that we can have this carry, and in addition to this example, we can have in other cases where we have to check if the carry is set at the end, because we might have a case like if we take the examples, like example 3 here, 99999 and 9999, and the result is 899990001. So this 1 isn't going to be there unless we do an additional check in the end. If the carry is set, add a new node with the carry. Okay, so let's start coding this. So we start with the list, a new list. I'll create a dummy node for this, and I will return the next element, so we don't return the dummy node, and I will initialize the current pointer. So we said we're going to iterate while either of the lists has elements and is not null, and then we said that we will have two things, a carry and a sum. So first we have a carry initialized to 0, and our sum also initialized to 0. Okay, so sum is going to be initialized to carry in the beginning of the iteration, because we might have a carry from the previous iteration. And then if L1, so if we have something valid in L1, what are we going to do? Well, we're going to add L1.val to the sum, and L1 is equal to L1.next, so we go to the next element. And similarly, if L2 sum plus equals L2 val, and L2 is L2 next. Okay, so that part is done. Then we still have to iterate forward in our newly created list. But before we do that, we have to create the next element, and that's going to be new this node of sum, like we said before. Okay. However, before we set it, we need to make sure that we set it to the right value, and sum must be a digit. So we do sum modulo 10, and the carry is going to be sum over 10. Right. Okay, so that covers the case that we saw on the drawing, and then we have this other case where carry could be set in the end. And then current next is a new list node, carry. And let's see, accepted and accepted. Okay, so the time complexity is going to be in turn linear with the size of the list, so O(n) or n plus m, because we're going to through all the elements in L1 and all the elements in L2. And then for the for space complexity, we will not have anything. It's going to be O1 because anything extra, because the list that we use to return the result is implicit in the problem. We cannot return a result without it. We don't have any extra space complexity used by any of our data structures here. So that's it for this problem. I hope you enjoyed it. If you did, like and subscribe, and stay tuned for more C++ problems. Thank you.